Hello, and thank you all for joining us for this ANZ Serverless Day session on green screening the serverless way. Before I get underway, I'd like to begin by acknowledging the traditional owners on the lands on which we meet today, and I would like to pay my respects to elders past, present, and emerging. So thank you all for joining us. We're really excited to be here and to be able to share some of the tips and techniques that we've discovered along the way of everything going virtual, everything going online, and in particular being able to bring some extra geeky fun to some of your video streams. So for those that don't know me, my name is Developer Steve, actually legally too, but that's a whole other story maybe for Q&A. I'm one of the developer advocates here at IBM, mostly covering the Australian-New Zealand region. And I'll also be joined in this session today by Cong Nguyen, a friend and also fellow developer advocate from the ANZ IBM developer crew as well. So a lot of what we're talking about today has sort of come about from a lot of the events that have not only gone online, but we have been involved with by doing talks, workshops, etc. And so we're really looking for that way to, well, to spruce up our video a little bit and make it a little bit fun. Just a side note before we continue, if there are any community organizers or group organizers in this session that are interested in sponsors and us being involved, please reach out and reach out and have a chat. One of the ways we've been engaging with a lot of groups and being able to help them sort of do the amazing things that a lot of the developer groups do is through this virtual venue platform, which allow for folks to be able to jump around multiple tables and have all those side discussions again. And one of the things I'll be talking about today is also how we've live streamed into these venues. So and this was really important, particularly for hackathons, to really bring those nice nuances back to events, was having that the video streaming for the run of stage while people were sitting around their tables, so they can still keep talking, still keep getting ready for a hackathon or just geeking out at a conference, but at the same time you can have a nice video stream come into the event itself. So, and we do have a bit of fun with these maps, so fully customizable. There's a workshop island, there's even a spaceship that we ran a call for code on. And that's a lot of what we'll be talking about today, sort of the events that we've tailored a lot of the video production stuff, particularly on the fly, to cater for these events. And Call for Code, which only just finished, but it will be back next year, was one of the first events that we had to build a lot of this as we were going and as we were pivoting. Like most others, the pandemic has affected particularly a lot of events, as we all know. So particularly that virtual venue and even some of the video stuff we'll be doing today was to try and make it as close to IRL or in real life as possible. So I'm sure most of you are familiar with OBS or Open Broadcasting Software. Completely open source, does an amazing job. In particular, Chroma Keying on the fly. And anyone looking to do green screening things or getting a green screen set up. One of the things I can highly recommend is some really good lighting. So having the green screen is one thing, but then having the light to be able to get that nice green background happening so that you can chroma key that out is like critical. So part of my setup, I've got, as you can see there, I've got a green screen. I'm actually using a Blue Yeti microphone, and I've got two fluoro studio lights on me right now. Special mention to not looking at the studio lights, because I've done that a number of times and you generally can't see anything for a couple minutes, so don't do that. But yeah, using OBS, and then initially we were using OBS with some filters to be able to take out the background and then put some nice fun backgrounds in behind us. To give you an idea what that looks like, here's a scene with me and Chewy from that slide. So as you can see, it makes things nice and fun, and well, it's just fun. You can also use it for presentations as well, which is, well, basically what I'm doing now. Spoilers. Anyway, so how this actually works, and in particular with a lot of our live streaming, what we're finding is we needed to bring a number of people into the stream out. So, and I know there's a number of platforms that do this fairly well. We were looking for something that we could, build out to how we needed to operate on the fly, which was amazing. And special mention to Cong, who was the video producer or the streaming producer on a lot of our live streams, often while he was presenting as well. But for those that don't know, there's actually a really hidden, and yeah, we took some digging to find this, but Skype is actually how we've been doing it. So Skype NDI has a hidden NDI setting, which is really buried inside the settings. It's basically inside settings, calling, advanced calling, and as you can see there's this great little switch which allows you to get multiple NDI feeds out. And why that's important is inside OBS, if you use this plugin, so OBS NDI 4.9, completely open sourced and runs really well. But what it allows you to do is grab any of the either speakers, active speaker, or share screen from a group Skype call and be able to funnel that into your OBS scenes. It even lets you do transitions between scenes. And yeah, you can pick up and pretty much do whatever you need to from there. So those that came to our Call for Code hackathons this year, our run of stage, we had a lot of demos running, sometimes with some of our partners like Here Technologies and Telstra, etc. What we do is get everyone onto a Skype group call and set up the scenes either on the fly or before they were being broadcast. And then just using this same technique and then streaming out to Twitch, YouTube, wherever you needed it to go. In our case, we were using Twitch into that virtual venue. Probably the biggest thing we very quickly discovered, we're all Mac users. So OBS on Mac doing Chroma Key uses a lot of CPU. So this is actually my CPU recorded earlier, just with OBS running. And yeah, as you can see there, it's sitting around 650%. There was a hackathon I ran, a meetup I ran only just the other week where it was running at 1100% of CPU. So, and that's on an i7 Mac with 16 gigs of memory. So it should actually have enough to be able to run, but it's like, this has really been driving us crazy. This is a massive problem. And I mean, the trade-off is those really nice scenes versus CPU, right? So what we looked to do was how can we do this processing online? This is a discussion like I've had with a number of people now, just geeking out, trying to work out some of the easier ways to be able to not only stream those multiple feeds in from different folks as we need to sort of stream it out, but also just like your normal regular video feed out. And it's where cloud functions or serverless sort of gets really, really interesting because, well, one of the cool things I like about serverless is these are functions that just sit there until you need them, like until they're called, until they're activated. So you don't have a whole lot of infrastructure just sitting there waiting for something to happen or waiting for something to trigger it. You can just have these code snippets even chained together to create a really nice stack, which a lot of companies are doing. So what we were set out to do once we identified like the problem statement, which is OBS using too much memory or too much CPU rather, was to pick up a camera feed, funnel it through to some serverless functions, particularly using either ImageMagick or OpenCV. So one of the code samples we're going to be looking at in a little bit uses ImageMagick, but I know that's not the most ideal thing to use for video in particular, but OpenCV's got some really cool functions. We'll get into that though. So we did some digging behind the scenes in OBS. Again, big credit to the community that's sort of built up there. In particular, OBS has a lot of contributors and it's a very long running project. Like it does video editing, video streaming really, really, really well. Like with the proviso that, on Mac, it runs quite high in the CPU category. But there's a whole bunch of forum posts around this. And so what it actually is the Chroma Key filter, which uses HLSL or high level shading language, essentially for DirectX, which, well, it's not made native Mac. It's a Windows thing. But we started digging around the plugin to see if there was anything we could do to try and help the shader. And I know a lot of folks, particularly from the community, have looked at ways to be able to alleviate this and essentially assist in building out the plugin. HLSL, such a tongue twister. Like I said, runs inside DirectX, and it is possible to run this inside Docker and do some processing inside Docker. But again, we were looking for a solution that would essentially fire up and process as we needed it to with extremely low latency. Not asking too much, right? No. But one thing, which is why we wanted to really go down the serverless path, because it basically helps with the video rendering side of things, but only when we needed it. So we won't have complex infrastructure or any infrastructure sitting there running unless we needed it to run. And so one of the code samples we initially started with was a GitHub repo and a code sample from fellow IBMer Belinda Venenum, who put together this really cool code sample and video tutorial on leveraging cloud object storage for image processing in a serverless environment. Essentially, it almost does everything we need except for the cloud functions part, which is actually sending through visual recognition to Watson Visual Recognition to do some processing on the image through AIML, and then send the image back. And that's just using two buckets, basically, for the unprocessed and then the processed image with some trigger scripts in between. For this code sample, Belinda's using a JavaScript function and image magic to basically process the image on the fly, send it over to Watson Visual Recognition, and then send it back again into a bucket, and then that's all displayed through a front end interface. So as you can see here, this is the code sample. This is the front end to it. You upload image. Go into cloud storage, you'll be able to see the initial images there. The trigger, which will trigger when something appears into that first bucket, will then pass through the cloud functions out to what's in recognition and then into a process bucket, essentially, which will then be displayed back onto the front end portal. So the code that Cong's going to walk through is basically us sort of changing some of those core cloud functions into using OpenCV Python, but in particular the headless one, of course, because, well, we're running cloud functions. And so now Cong's going to demo the code that we swapped out for. Now this code will be available after this talk, but we'll get into that a little bit later. So over to you, Cong.
Well, thanks, Stevie, for the intro. Well, just before I go into how the things work, I just want to touch on another way that you can alleviate the 600% CPU increase when you are using OBS on a Mac, and that is to not do the green screening and the composition of other effects on the Mac itself. So if you use NDI, you effectively can send the video feed with a green screen over the NDI feed over your LAN network to a dedicated machine. And for my setup, I use a Windows machine. Once the Windows machine has processed the green screen, remove it, it will send then the feed again through NDI to my Mac, which is combined with the screen capture and whatnot, which then will be uploaded to Twitch. So when we first started out this project, I wanted to modify the OBS source code and just run libobs, which is the library that powers OBS, and the shader library, the shader effect just by themselves in a cloud function. However, the shader requires a GPU, and given at that time that we were doing a code for code hackathon and didn't quite have enough time to spend on this project, we opted out for the easy way. To be able to use this, a user first creates a session by sending a post request to the IBM Cloud function to create a new session. This will return with a session ID and create an endpoint where OBS can then use to capture the browser, which is navigate to that endpoint. Then on the user's machine, a Python application splits the video feed into frames and then send them frame by frame, starting with a session ID, ending with a timestamp into a frame input bucket in a cloud object storage. The cloud object storage is being set up to trigger an action or a series of actions in the IBM Cloud function. The frame input bucket, when it receives a new frame, triggers an apply chroma filter function. Then this apply chroma filter function filter out the green color and write the filtered frame into the output bucket. Once it's received a frame in the output bucket, it then triggers another function which updates the image intersection link, which sends a new frame to the endpoint. The browser, where the browser shows up that new image, and OBS can then seize that image and use that in the production. IBM Cloud function is built upon Apache OpenWhisk. The cool thing about Apache OpenWhisk is that it can run Docker containers. Yay! So for this particular project, when running on a function or an action in this case, I'm using the OpenCV Python headless version, which doesn't render the image input or output, so there's some savings there. But just to walk you through how the code works behind the scene, I've created a snapshot of the code with using the full-fledged OpenCV library for us to go through. So what I have here is a picture of Steve with the green screen in the background. Firstly, we import the OpenCV, the CV2 library, which is the Python binding for OpenCV, NumPy for doing some array transformation, and matplotlib just for this example because we are showing how things work behind the scenes. Step 1 is to read in the image. Images exist in the BGR color space. For the example, I need to convert into RGB color space. Videos that typically live in the YUV color space, which stands for lumina, chroma, and values. It's more efficient that way, and there are a lot of articles and tutorials online where you can read through to see why this is the case. But since we are dealing with images, I need to convert from the BGR color space to RGB for processing. Once I've done that, I then filter this image at every pixel that if it is within these color values, and these are green colors in RGB. In hue saturation value HSV, it's about 120 for the hue. So by filtering it, I get this silhouette of Stevie's, and by inverting the silhouette, I get to capture the background. So the second step will be to load in the background image. Similar to the first step, I need to convert the color space from BGR to RGB. Then I resize the background image to fit into the original frame's dimensions so they fit in nicely. And then we combine the two images together by overlaying the masked image, which is this image, on top of the background image that we resized, and the final result is this image below.
Thanks, Cong. That was amazing, and really glad that worked first time. I guess that is one of the good sides to pre-recording videos, right? You know your code's gonna work. The amount of demos I've done where something always goes wrong. Anyway, our biggest concern with a lot of this infrastructure stuff, particularly, is of course latency and lag. You don't want your video feed, particularly your video feed, to be able to have that delay where you mouse moving but there's no audio, or vice versa, like you have audio but there's no picture, or it's stuck in one particular scene. And so looking to build that out, one thing we are actively pursuing is a way to do this inside OpenShift. And in particular, we hate vendor lock-in. So we're looking to move it into a platform where it wouldn't matter where it was running or even how many clouds that this particular thing was running on. And that's one of the things I like about OpenShift and multi-clouding is you can move stuff around as you need to. But one of the other cool things with OpenShift in particular is you can actually hook up NVIDIA GPUs inside OpenShift as well. So you can add that into your cluster and get a lot more sort of video processing on the fly. Special mention to, there's this really interesting project called Project Sprocket. It's been around for a few years now, but it's basically a serverless video processing framework, which is really cool. And it's just sort of research that's come out of University of California in San Diego, but effectively using 1,000 workers to be able to process video on the fly. Sadly, it doesn't seemingly do Chroma Key, but someone please correct me if I'm wrong with that. At least we couldn't find much on it beyond the white papers and beyond some of the research. And we really, really wanted to use something like this to be able to process our video feeds. Interestingly, it appears to be fairly low latency, fairly low cost, depending how you configure the back end, but did seemingly have some really interesting features beyond having the Chroma Key that we needed. Which is really important because then you get to do fun things like dance with Jake and Finn. And so opening the door to further reading, or even opening new gateways into using, really to bringing some really cool effects to your video streaming. And I do like the GIF for that. There was a slight pun there. So some further reading. For those who haven't yet explored the world of chroma keying, I would recommend, this is a really good article talking about some of the things I talked about at the start with having enough light and then also having that green screen. The light and the actual green screen itself is like critical to this scene. I've tried to do this before without studio lights and well, you can kind of do it, but it does get a little bit pixelated and a little bit hazy depending what platform you're using or what your code looks like. So I highly recommend getting some really good lights if you are looking at getting a green screen and getting set up to do it. The GitHub I was talking about earlier, so github.com/IBM/cos trigger functions by Belinda. That's all on our GitHub. And then also the code that we talked about today and the code samples are all on developer.ibm.com as well. Thank you all for joining us. Hopefully you got something out of it today. We are around for questions. Wait, I get to wave to myself now. Hi, Developer Steve. Wow, that's really weird to say. Anyway, the thing I always like leaving my sessions with is please use your developer superpowers for good and, of course, be excellent to each other. Thank you very much.